Dr. House, there is a seriously injured patient in the ear. He has a stabbing from a dancing accident.
Really? How do these people get these kinds of injuries?
Well, Dr. House, we really must do something. For his vitals, he has a heart rate of 92, a respiratory rate of 22, a blood pressure of 95/65, and is still conscious.
Well then, that does seem enough. Tell you what, hook a pulse oximeter to him and keep an eye on his oxygen levels. Also, hook him up to an IV drip so we can give him saline. It looks like he has a laceration in an artery and that's why his blood pressure is so low.
Yes, doctor. Okay, doctor. I have just done what you said. The patient should be on his way to recovery.
What is that mysterious siren noise? It's not from over here. Not from over there. It's just the patient dying? The patient died.
What? Dr. House, how can this happen? Everything was going just fine.
Well, let's see. You hooked up an IV drip to the patient, so let's trace the IV back. And what should be saline is really distilled water? Nurse, what have you done?
Doctor, I just did what you told me to do.
I didn't tell you to kill the patient. You bubble-headed nurse. I should never trusted you with a serious patient. Do you even know why this happened?
Well, yes, Dr. House. Due to my mishap, the water, through osmosis, transferred from the hypertonic, or less concentrated, area to the hypertonic, more concentrated, area. Neither area was isotonic.
So do you know about osmosis and diffusion?
Well, osmosis is the diffusion of molecules through a semi-permeable membrane from a lower concentration to a higher concentration until the concentration on both sides are equal. I'm not too sure about diffusion. Can you explain it, Dr. House?
Diffusion is the passive movement of a substance from a low concentration to a high concentration. Passive transport is low to high concentration, while active transport is high to low concentration. Active transport requires energy while passive transport does not.
Also, both osmosis and diffusion require materials to pass through the semi-permeable membrane from the extracellular site to the intracellular site.
Exactly. So, when all the water rushed into the patient's blood cells, it caused hemolysis, the explosion of blood cells.
So, you mean to say that my little mistake of changing saline with distilled water caused the patient to die?
Yes, of course. Another way to explain the phenomena is to reference the lab the researchers did last week. They put starch in a plastic bag and put the bag in a container of iodine and water solution, and the iodine passed through the barrier of the plastic bag to the starch. In this case, the plastic bag was the cell membrane. This happened because the starch was more hypertonic than the iodine and water, or had more concentration. This made the iodine and water hypotonic to the starch, or had less concentration. Neither area was isotonic. So, this is a reason why the distilled water is so harmful to the patient.
Yes. I seem to remember this experiment. It showed me the beauty of osmosis.
Yeah. So as I was saying, do you know how this would disturb homeostasis in a human body?
Well, wouldn't most of them end up like our patient? Dead.
He's dead. Well, yes, they would. I guess all of this talking distracted me from noticing our patient was dead. And no, there are other ways. Osmosis helps maintain homeostasis. For example, water in the blood cells can cause water intoxication. This is especially frequent in children and athletes. This is the reason that athletes prefer to drink something filled with electrolytes, such as Gatorade, as opposed to water.
Doesn't osmosis also help the kidneys? If harmful solutes come into the bloodstream, osmosis will help filter it out the harmful solute.
Very good. You're actually learning something.
Interesting. but I still feel bad about killing the patient. Is there anything I can do?
Either rub some dirt in it or go home and cry about it. And you're fired.